Okay, page 6 of binomial expansion. 6a, write down the first 6 rows of Pascal's triangle. No big deal. Right here, okay. Find the sum of the numbers in row 1, row 2, row 3, row 5, row 4, and row 5. So, I don't know what they mean by first 6 rows of Pascal's triangle. I don't know if they mean up to this row, if they mean this row too, but I went ahead and added up all the rows till the end. So I got 1, 2, 4. 1 plus 3 plus 3 plus 1 is 8, and 16, 32, 64. It's an interesting progression. You can see that these are numbers that are doubled steadily, or they are maybe powers of 2, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, right? Copy and complete the numbers of rows in Pascal's triangle. The sum of the numbers of the Pascal's triangle in row n is, so if you consider this to be row 6, it's equal to 2 to the 6th. If you consider this to be row 7, it would be 2 to the 7 minus 1, so 2 to the n minus 1. So it depends on, I don't know what they call row. To me, the 7th row would be this one, but I think they call this the 6th row. Okay, show that 1 plus x in parentheses to the n power equals n chooses 0 plus n chooses 1 times x plus n chooses 2 times x squared. And the final term is n chooses n x to the n. Okay, and this is not rocket science. It's what we've been doing all this time. Okay, so it's pretty easy, right? Pascal's triangle coefficients, n chooses 0, n chooses 1, n chooses 2, all the way to n chooses n. The a term is 1, so it basically just disappears everywhere. The b term is x, so you should see x to the 0, x to the first, x squared, all the way to the x to the n minus 1, and x to the n, right? So that we've confirmed that this is indeed the expansion of 1 plus x quantity to the n. Hence, deduce that all the Pascal's triangle coefficients are equal to 2 to the nth. Okay, so let's do that. Let's say that this sum is similar to this sum above, except for the fact that this has no x variables, and this one does have x variables. Well, what if we took this expression here and we just set x equal to 1? Wouldn't that make this expression equal to this expression? It does, right? It would transform into this expression here. So if this expression is equal to this expression, when x equals 1, why don't we put 1 here in for x? So then we would have 1 plus 1 quantity squared to the nth power, which would be 2 to the nth power. Oh, so actually, if we make x equal to 1 in this upper equation here, we are showing that 2 to the nth is equal to all the Pascal's triangle coefficients added together. Okay? So here we saw that if we say the row number is actually 7 here, it's 2 to the n minus 1. But if we say that this is 6, if we say that this is row 6, then we could say it's 2 to the n. So that confirms that, right? Okay, let's go to number 7. Number 7. Okay, 7a. Find the coefficient of x to the 5th in the expansion x plus 2 times parentheses x squared plus 1, close parentheses, to the 8th power. Interesting. Okay, so here we have a binomial that is not the same as this binomial times a binomial expansion. So the first thing they want us to do is they want us to figure out what the coefficient of the x to the 5th term would be. That's a hard one, because like, do you see how this is multiplying times x and it's being multiplied by 2? The x and the 2 have to be distributed into the binomial expansion. So let's say that there is an x to the 4th term in here. If the x to the 4th term multiplies times x, we would get x to the 5th, right? If we had an x to the 5th term inside here and we multiply it times 2, we would also get an x to the 5th term. So let's check that out. Let's try to find when this binomial expansion has an x to the fourth term or an x to the fifth term. To do that, we're going to do something similar to what we've been doing earlier. We are going to write the general term, which is n chooses r times a to the n minus r times b to the r. Well, in this case, r, we don't know yet. N is 8, right? A is x squared and b is 1. So the b term is easy because the b term, since it's 1, it just disappears. The Pascal's triangle coefficient is going to be a chooses r. We don't know what r is yet. And then we have x squared, which is the a term, to the n minus r power, 8 minus r power, okay? And now we're going to say, okay, now we got this general term expression. When does this general term expression have x to the fourth or x to the fifth? Let's do x to the fifth first. So we're going to take this expression here, and we are going to set it equal to x to the fifth. Do you notice how we just took the x part of it? So I'm just going to color that in green. So the x part of it, is here. So I'm going to set the x part of it equal to 5 to x to the fifth. And then I'm going to take the x part of it and test it with x to the fourth also, okay? So if I say x to the x part of it, which is, I've simplified it, x to the 16 minus 2r is equal to x to the fifth, then I just need to figure out when does 16 minus 2r equal 5? And it may seem like there will always be an answer to this, but we have to keep in mind, did you know that like r must be an integer, okay? Since r must be an integer, you can like go ahead and finish this. You could say, oh, 2r equals 11, r equals 5.5, but actually r can't be a non-integer. If r is a non-integer, then it doesn't work, right? Because the r value has to determine the position in the binomial expansion. It has to be a whole number. So there is no solution for 16 minus 2r equals 5, okay? So let's look at when x to the 16 minus 2r equals x to the fourth. That would be this case here. 16 minus 2r equals 4. So 12 equals 2r. 12 equals 2r. We're going to divide both sides by 2. We get r equals 6. Okay, r equals 6. So if we know that r equals 6 is the only solution because this x to the fifth possibility led to no solution, then we go back to the general term and we say, okay, we know that r equals 6. Let's put r equals 6 here. Let's put r equals 6 here. What do we get? 8 chooses 6 times x squared to the 8 minus 6, which is also 2. 2 times 2 is 4. So we get x to the fourth. So we get 8 chooses 6 times x to the fourth. Now, since it's the x to the fourth term, we have to remember that we do need to multiply the x to the fourth term times x in order to make it into an x to the fifth term, right? So we have x times 8 chooses 6 times x to the fourth. Okay? So that would be 8 chooses 6, which happens to be 28, times x to the fifth. That is the term for this expansion. So we have the x to the fifth term, 8 chooses 6 times x to the fourth, 28x to the fourth, and we multiply that times this x term, we get 28x to the fifth. Okay? All right. Let's move on to problem 7b. Okay. Now we're going to find the term containing x to the sixth in the expansion 2 minus x times 3x plus 1 quantity to the ninth. Simplify your answer. Okay. All right. Oops. This is a little bit more challenging because there's actually two terms in the binomial expansion that can satisfy this. Okay? So first step, as usual, is we're going to write the general term formula with the information that we know. So 9 chooses r, n chooses r becomes 9 chooses r because we do know that the binomial expansion has 9 as the power. The a term here is 3x, okay? So 3x to the n minus r power, which would be the 9 minus r power. And the b term is 1, so it just kind of disappears, 1 to the r, okay? And then we want to know how to get the x to the 6th term. There's two possibilities. One is we could have x to the 6th here, and then it multiplies times 2, and then we already have part of the x to the 6th term. The other part could come from an x to the 5th term here, multiplied times the minus x. That would give another component of the x to the 6th term. So we need to check out both things. We need to check, when does the binomial expansion equal x to the 6th? When does it equal x to the 5th? Because both of those could lead to part of the x to the 6th term in the final multiplication. So we divide the two possibilities up. So we take the green part of the general term expression, which is x to the 9 minus r. We know that x to the 9 minus r is the only x component in the whole general term. So we're going to take the x to the 9 minus r. First, we're going to equate it to x to the 5th. We're like, when does the binomial expansion have an x to the 5th term, which, when multiplied times negative minus x, would become x to the 6th? When does the binomial expansion have a x to the 6th term, when multiplied by 2 would still become x to the 6th? Okay? So let's look at x to the 9 minus r equals x to the 5th. Okay? So 9 minus r exponent at some point, does it equal 5? 9 minus r equals 5. If we solve that with algebra, we get r equals 9 minus 5 equals 4. So when r equals 4, we generate an x to the 5th term. What about when x to the 6th? So 9 minus r equals 6. R equals 9 minus 6 equals 3. So r equals 3 or 4 generates an x to the 6th or x to the 5th term, which, when multiplied times the binomial 2 minus x, generate parts of the x to the 6th term. Okay? So let's see exactly what that looks like. So let's take the x plus, oh, actually it's not x plus 2. It's the 2 minus x term. Sorry about that. I wrote this part wrong, but the rest of it is miraculously right. Okay. So the 2 minus x binomial, which is multiplied times these two terms, is broken up here. First I took the negative x and I put it here, and I put the 2 and I put it here. The negative x is going to multiply times the orange term, because negative x times the x to the 5th term will yield an x to the 6th term. The 2 part of this is going to multiply times the red term, because the x to the 6th red term, when multiplied times the 2, continues being an x to the 6th term. So let's take the negative x, and we're going to multiply it times the general term with r equals 4 plugged in. So we have 9 chooses r, 9 chooses 4, right? 3 to the 9 minus r. 9 minus r would be 9 minus 4, so it would be 3 to the 5th. And then the x part of it would be x to the 9 minus r, or x to the 9 minus 4, x to the 5th, right? And the 1 would just kind of disappear. The red part would become 9 chooses 3, because the red part is going to be r equals 3. And then the exponent for 3 would become 9 minus 3, which is 3 to the 6th. And the exponent for x would be x to the 9 minus 3, which would be x to the 6th also. Then I multiply the negative x times this, I multiply the 2 times this, and I get the term more specifically to be negative 9/4, because there's a negative here, 3 to the 5th, x to the 6th. And the second one becomes 9 chooses 3 times 2 times 3 to the 6th times x to the 6th. So the bottom one becomes 122,472 x to the 6th. The top one becomes negative 30,618 times x to the 6th. And if I add those two together, because these are two separate terms that have x to the 6th components, we get 91,854 x to the 6th. Okay, so that's it for this 7b. Let's look at 8. Okay, 8 is a similar type of problem, a little bit of a twist. Consider the expression x to the 6th, sorry about this vertical line here, just ignore it, y minus 2y squared, close parentheses, to the 6th. Find the term in which x and y are raised to the same power. So this is different than what we've done before, but you can kind of imagine how to do it. First step, as usual, write the general term with the information we have filled in. We know that n equals 6. We know that a equals x squared y. We know that b is negative 2y squared. So we fill all those in. So 6 chooses r. 6 chooses r is our Pascal's triangle coefficient. The a term x squared y is taken to the n minus r power, 6 minus r power. The b term, negative 2y squared, in parentheses, is taken to the r power. Now what I did here is I separated the variable components from the number components. I left the number components white, and I took the variable components and I colored them. The variable component x was colored kind of green, and the y component was colored kind of orange. And then what I did was I said, well, didn't it say that the x variable exponent was equal to the y variable exponent? So I just took the green part, which is x squared to the 6 minus r, and then I wrote out the orange part, which is y to the 6 minus r times y to the 2r, and I said, hey, I simplified this by putting together the exponents, same base twice, so I added the exponents, so 6 minus r plus 2r becomes 6 plus r. Then I equated the exponent for the x, and I equated it to the exponent for the y. So 2 times 6 minus r equals 6 plus r, because they said find the term in which x and y are raised to the same exponent. So 2 times 6 minus r is actually 12 minus 2r. Set that equal to 6 plus r. I just do some algebra. Add 2r to both sides. I get 3r on the left, or the right, and I have 6 on the left. R equals 2. Okay, then I take the general term again, and now that I know what r is 2, I can put it back into the general term, and now I have 6 chooses 2. X squared y to the 6 minus 2 power times negative 2y squared to the 2 power. And I simplify everything. I end up with 6 minus 2 equals 4. I distribute this squared to both of these inside. I separate out the y components, so it's y to the 4th, y to the 4th. Y to the 4th times y to the 4th is y to the 8th. X squared to the 4th is x to the 8th. And the negative 2 squared is actually just 4, but I didn't even multiply it out, because the important thing is that, yes, we did find that this term is the term in which x and y are raised to the same power, which is 8 and 8. So I have the Pascal's triangle coefficient, 6 chooses 2. If I multiply that times 4, that would give me the coefficient. Okay? Since it asks for the power, we would want the coefficient x to the 8th, y to the 8th. We would want the whole term. Okay? But, so you could do that with your calculator, or you could do it by hand. All right. But on the test, if they asked you that, you would definitely go to the end. All right. 9a. 9a. The third term of the quantity 1 plus x to the nth power is 36x squared. Find the fourth term. Okay, this is a little bit different than usual, isn't it? So let's just, first of all, confirm that the third term would be 36x squared by using the Pascal's triangle coefficient n chooses 2. Why n chooses 2? Because n chooses 2 is the r equals 2 Pascal's triangle coefficient. R equals 2 when it's the third coefficient. So n chooses 2 is equal to 36. How do I know? Because look at the binomial. The binomial is 1 plus x. So there are no numbers here to make coefficients that are not the Pascal's triangle coefficients. If you have just 1 here and 1x here, when you expand this, you're always just going to get the regular Pascal's triangle coefficients 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, right? You're not going to get anything bigger than that. So we know that the coefficient here, 36, x squared, that means that the Pascal's triangle coefficient is 36. So we're going to set n chooses 2 to 36, okay? And then from this, we can figure out that n equals 9, okay? Now, you could probably do this with algebra, but probably the easiest way to do this is just to do a few on your calculator. Do like 10 chooses 2, that's too big. Do 5 chooses 2, it's too small. And then just test a few, and eventually you get to n equals 9. Okay, if you would like to know how to do this with algebra, we can talk about it, but probably this is going to be a calculator problem. So go ahead and like push a few buttons on your calculator, find out that n equals 9. Okay. Then we know that actually it's not n chooses 2, it's actually 9 chooses 2. So if we want to know the fourth term, all we need to do is find out what 9 chooses 3 is, right? Because 9 chooses r equals 3 would be the fourth term. So 9 chooses 3, do it in your calculator, you get 84. And then, of course, the variable part of the fourth term would just be x cubed, because the fourth term would be x cubed, because the second term was, or the third term was x squared, the second term was x, and the first term was x to the 0, right? So that's how we know it's 84x cubed. So that was pretty easy, right? Now let's do part B. If the quantity 1 plus kx to the n equals this polynomial, find the values of k and n. And dot, dot, dot just means it continues on, but they only gave us the first 3, so we only have the first 3 terms to figure out what the heck is going on. So we need to find the values k and n. Well, k and n. How does that affect how do k and n affect the first term? Well, remember, the first term is just a to the nth power. And since a here is 1, and n doesn't really matter, if you take 1 to any power, it's going to be 1. This gives us no information, does it? So the first term is worthless. But one good thing about knowing that a equals 1 is we know it does not contribute to any of the other terms. So when we look at the second term, negative 12x, we know that this negative 12x comes purely from kx and the Pascal's triangle coefficient. We don't know the Pascal's triangle coefficient, the second Pascal's triangle coefficient, because we don't know n yet, okay? So let's see what we're going to do. First thing we know is that the second coefficient, even though we don't know the Pascal's triangle coefficient, we do know that the second coefficient is always equivalent to the power. So the Pascal's triangle coefficient here is n, right? Because the second term always has the power as the Pascal's triangle coefficient, right? 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, right? So this is always equal to the power. So we know the Pascal's triangle coefficient is the power. Then we know that the b term is taken to the first power, so kx is to the first power. So we know that nkx is equal to the second term, negative 12x. Well, x is equal to x, so that we know the nk is equal to negative 12. So the Pascal's triangle coefficient and this k coefficient multiplied together give us negative 12. Okay, that's a good clue. So we kind of don't know k yet, we don't know n yet, but we do know that when n and k are multiplied together, we get negative 12. That's interesting. Okay, now let's try to use the 60x squared to give us more information. Okay, so 60x squared happens to be the third term. The third term, r equals 0, 1, 2. So n chooses 2 for the third term is the Pascal's triangle coefficient. The k squared comes from, okay, so when you have the third term, this would be b to the 0, this would be to the first, and this would be b squared. What's b? Kx. So b squared is actually k to the k squared x squared. So k squared, there I have it right there. So the b squared term becomes k squared x squared. Now I am going to set that equal to positive 60, because we know that the coefficient for the third term is 60, and we know that the Pascal's triangle coefficient is n chooses 2, and we know that there's a k squared contribution from the coefficient of kx. Okay, so we know that n chooses 2 times k squared equals 60. Okay, so we still do not know n. We still don't know k, but remember, we do know that n times k is negative 12. So let's try a few numbers that multiply together and get negative 12 and see if we can find which combination makes 60 here. Okay? This might sound like a horrible way to do it, but really there's not too many possibilities, so you're going to be done in a flash. Okay? It's probably better than any kind of algebra way. I don't know. Probably more fast. Easier to understand anyway. So, what are the possibilities? Well, it might seem like there's an infinite possibility of numbers that multiply together and get negative 12. But remember that if you say that n and k both have to be integers, and not only that, but n has to be a positive integer, then it seriously limits the choices, right? So I could say that n could be 3, 4, 6, maybe 2, okay? But there's no other values that n could be that are positive integers where multiplied times k would give me negative 12, right? So let's try 3, 4, and 6. N equals 3, n equals 4, n equals 6. Let's figure out the k values that when multiplied together with n would give us negative 12. So paired with n equals 3, you'd have k equals negative 4. Paired with n equals 4, you would have k equals negative 3. And paired with n equals 6, you would have k equals negative 2. Okay? I don't remember why I dismissed n equals 2, k equals negative 6, but for some reason I did. Okay? And it didn't affect me because that wasn't the answer. So first we'll try n equals 3, k equals negative 4. When we try to put n equals 3 and k equals negative 4 here, we can see that we're never going to get 60 because once we put k equals negative 4 into k squared, we're going to get 16 here. Well, I got news for you. There's no integers you can multiply times 16 to get 60, so this one's out. Okay? Let's try n equals 4, k equals negative 3. So when k equals negative 3, you put that into k squared, you get 9. So, more newsflash, 9 times an integer will never give you 60, so that one is also out. Let's try our last option, n equals 6, k equals negative 2. When you put k equals negative 2 into k squared, you get 4. That looks promising because 4 is a factor of 60. Then you put n equals 6 into n chooses 2. We're going to have 6 chooses 2. So now, we have 6 chooses 2. Let's test it. 6 chooses 2 is 6 times 5 divided by 2. So that would be 3 times 5, which is 15. 15 times 4 is 60. All right, so we found the answer. So the combination of n and k values that work out, that multiply together and get negative 12, that fill in this expression and give us 60 are indeed n equals 6, k equals negative 2. Okay? By the way, if you did try n equals 2, k equals negative 6, if you put k equals negative 6 into k squared, you get 36. Also is not a candidate to multiply times an integer and get 60. Okay, so, all right, let's move on to number 10. It's the last one of this grueling problem set. Okay, find a if the coefficient of x to the 11th in the expansion x squared plus 1 over ax to the 10th power is 15. Okay, so, first we're going to make the general term formula customized with the information we have. Surprise, surprise. So the Pascal's triangle coefficient, instead of n chooses r, is going to be 10 chooses r. The a term is going to be x squared to the n minus r power. N is 10, so it's 10 minus r power. And in the denominator, because the b term is basically 1 on top and some information on the bottom, in the denominator we're going to have a to the r and x to the r because the b term is to the rth power. So a to the r times, and b to the x to the r on the bottom. Now what we're going to do is we're going to color code the variable information because we're looking for the coefficient of the x to the 11th term. So let's figure out when the green part equals x to the 11th. So let's set the green part equal to x to the 11th and then see what r was going to equal to make it equal. So the top is going to be x to the 20 minus 2r. The bottom is going to be x to the r. You see I'm ignoring a to the r because a to the r is not the variable part. Then I'm going to write this as one exponent by taking the top exponent and subtracting the bottom exponent. I get 20 minus 2r minus r, which would be 20 minus 3r. Okay. Now what we're going to do is we're going to take the exponent 20 minus 3r and we're going to set it equal to 11. So 20 minus 3r equals 11. 3r equals 9. r equals 3. Okay? So now that we know that r equals 3, we're going to come back and put r equals 3 into the general term. And that gives us this expression here. 10 chooses r becomes 10 chooses 3. X to the 2 times 10 minus r becomes x to the 10 minus 3, which is 7, times 2, which is 14. And on the bottom, we have x to the r, which is x cubed. So x to the 14th divided by x to the 3rd is x to the 11th. And wait, we just confirmed that indeed we found the term which has x to the 11th as the variable part. Okay, so let's try to figure out the coefficient now. So, we know that the coefficient is 15. So let's figure out what a is, now that we know that the coefficient is 15. So what we're going to do is we're going to set the number part, which is 10 chooses 3, and a cubed is at the bottom. Even though this looks like a variable, a is like a constant, so it's the number part, okay? So we put 10 chooses 3, and we have 1 over a cubed multiplied times it, and we set that equal to 15. Okay, 10, and if you do algebra here, you get a cubed on the left, and you put 15 on the bottom. You get a cubed equals 10 chooses 3 divided by 15. Hold on, we're at the home stretch. 10 chooses 3, if you do it without the calculator, is 10 times 9 times 8 divided by 3 times 2 times 1. The 3 cancels out with the 9, you're left with 3. The 2 cancels out with the 8, you're left with 4. 10 times 3 times 4 is 10 times 12, which is 120. 10 chooses 3 becomes 120. It's divided by 15. That gives you 8. You can use a calculator to do that. A cubed equals 8. A has to be 2, right? Because 2 times 2 times 2 is 8. You don't need the calculator for that. And we have solved the problem. And man, that video was really long.